So I hope you caught Jason's talk this morning about the edge cloud, because it was a really nice perspective on, there we go, now we got them in the right order. Really nice perspective on all the parts, and you got devices, you got the commodity cloud, you've got telcos in the middle. And he really gave you a very clean picture, and I really, really like it. But he started his talk by saying everybody's got a different perspective. And that is in fact the case. And so this is going to be the messy session. We're going to give you some different perspectives. I'm going to get it kicked off a little bit, and then everyone's going to have a chance. These three guys are all with startups. So it's a little bit of a unique opportunity, not from hearing from the big guys, but from the guys that see opportunities coming out of the edge cloud and how they're going to pursue that. So I'll let them introduce themselves in more detail, but John Wiqar and Zack will be talking about their companies just very quickly as to what they see as the opportunity. And then we're going to open it up for discussion. I'll ask a couple questions, but I'm going to encourage you to ask questions, and I'm going to encourage them to ask each other questions. What I wish we could have done is bottled what happened in the back of the room when we were all getting mic'd up, because it was a very organic back and forth as they met each other. Now, I know all three of these from having dealt with them. I did not go out. I know this is Silicon Valley, and I could have gone out to the street and put up a sign saying startup wanted for a panel session, edge cloud, and I probably would have got a lot of takers. But these are folks that we've been working with at the ONF. So I really do not want to spend a lot of time talking about the edge cloud or why the edge cloud. We all know how important it is. I just used my two favorite over-the-top hype quotes just to get you psyched about how important the edge is. And so let's go on from there to the next over-the-top diagram that I have, which is the collision course. I've been using this term collision course, and sometimes people object to it, but I actually hear people on both sides talk about the collision course that we're on. So I'm gonna stick with that. So on the one hand, we've got cloud providers, and they've been back in their data centers, and they're about to move out to the edge, and they need to do that for latency reasons, they need to do it for bandwidth reasons, massive scale of IoT, autonomy reasons. There's a lot of good reasons why you need to get out of the data center and move to the edge. And at the same time, for the last several years at the ONF, we've been working with the operators that have access networks, and what are they doing? They're trying to adopt all the same technologies that the clouds have been using and bring it into what they already own at an edge in their central offices. And so disaggregation, white box commodity, and everything being software defined. So what do you get when these two things happen? You get a collision. And while I could have done better, more spectacular graphics there, that collision really to me means that there's opportunity. And we see the opportunity at the ONF, and the operators, by the way, both with access networks and clouds are partners. And these guys see opportunity, and their startups see opportunities. So let me give you one little bit about the ONF perspective on the opportunity. And from our perspective, dealing with the Comcasts and AT&Ts and Deutsche Telekoms on the one hand and the Googles on the other hand, all partners and all part of this, we're really looking at the combination of access and edge cloud. And is there an opportunity to converge, in essence, that we can build platforms that do both access technology, and that's where some of the functions can move to the edge. By the way, if you just Google democratizing the network edge, you'll find a paper I and several others have written about that opportunity. I'm not going to go into any more detail, but you get the idea because you've been hearing about Corp and the like for quite a while. Well, again, we have three startups that see different opportunities. I'm going to give them each a chance to say what they see as the opportunity. This is a huge space, and everyone understands we don't want to boil the ocean, and these gentlemen have to figure out a way not to boil the ocean and to move their companies forward. So we'll get to see what their perspectives are. And before I get to them, and we'll do that in just 1 second, I want to put one picture in your head, which is kind of the convergence picture that we talk about at the ONF, which is, and it's exactly building upon the substrate you just saw in the previous session. And we view these as all components that allow us to load different profiles onto. And those profiles, from our point of view, we have the opportunity to put both access technology, whether it's 5G, PON, and the EPC, and so on, and the edge services co-located. And we're trying to explore what that means and why that's a unique situation. So just to put that picture in your head as we go to the individual talk. So let me now turn it over to John, I believe.
Great.
Thanks.
All right, thanks, Larry. So I'm John Dilley. I'm Chief Architect at Rafay Systems. We are a startup since late 2017, November 2017. I was surprised to learn as I met my co-panelists that we are the longest tenured startup on this panel. So there you go, at going on 2. So I want to take a few moments and talk about that convergence from edge to cloud in this context. Starting with the edge device, that may be an IoT device, a smartphone, whatever it is, this end user device, perhaps using 5G, accessing resources. This is where MEC comes in. So this is access meets edge, to use Larry's term. At the MEC, we have a set of capabilities. The multi-access edge cloud gives us some amount of compute, but what we will find is from the MEC, from the access network, applications will need to access more scalable, elastic, let me not use the word elastic, but scalable compute resource, CPU, RAM, TPU, like we were seeing earlier. So there's a natural movement from MEC, the device edge, if you will, to internet edge, where you have more compute power. And backing that, as we heard earlier today and yesterday, we have internet edge communicating and relying on those elastic resources in public cloud. The nature here of public cloud is you've got gigantic data centers. You can spread those resources across many customers. As you get to the smaller, you have the more dedicated, and we've been hearing this playing through. So we walk from the device edge, if you will, all the way to public cloud, and there's edge computing all the way in the device and the internet point. So what's my perspective on that? So I joined, and we've been building towards this notion of cloud edge and edge computing. But a funny thing happened on the way to the edge cloud. So as a startup, venture-funded startup, we have a certain amount of patience, but it's not as great as the operators or the large cloud providers. So we discovered that there are a set of key problems that must be addressed in order for any of this edge computing to be real. If you have an application and you want to deploy it all the way to the device edge, on my phone, in an access point by a base station, or in the internet edge, you must solve for a set of things that I call application lifecycle management. I didn't invent this. It's called app lifecycle management. This is container distribution and placement, moving code to the point where it needs to be, scheduling that code in cluster, orchestrating pods running on nodes, and then infrastructure and platform abstraction. So many developers, many of us in the room, are using Kubernetes to orchestrate, to do these in-cluster orchestration capabilities, and it's a great platform. But the learning curve is relatively steep. The number of people who have the deep Kubernetes and scheduling expertise is fairly limited. So in order to really enable edge computing to pop, I believe we need that infrastructure abstraction so that every developer doesn't have to think about each distributed systems problem. So I say edge cloud depends on application lifecycle management. And those network operators, and cloud providers and others, but it's the network operators that I'm really thinking about today, that solve this problem will win more applications, greater pace of innovation, greater pace of new entrants into the market doing cool stuff. A few more words about application lifecycle management. We talk about day 0, day 1, day 2. Day 0, not on this slide, that's when you get the infrastructure resource the processors, nodes, what have you. On day one, you've got the application up and running. You've set up the infrastructure, you've deployed your application, and you see it go. That's great. Now you can start sending traffic to it. Day two, as it's called, is everything after that. My dream is actually day 6 operations, if you will. In the Bible, we start with day 1 and go to day 7, but in computer science, we start at day 0. And day 6 is the day we rest. Unattended operations, this is the dream. So lifecycle management, what I want to leave you with in this session is configuration updates. I have a change to my network configuration, my application configuration. Container updates. I've got a patch, a security patch must go out, or capability patch. I've got new features that I'm deploying. And ongoing monitoring and tuning. These are all part of day 2 operations. I'll talk a little bit more about that in a session I have after lunch. In closing, what I want to leave you with is we're big believers in Edge Cloud. I think that the opportunities there are truly exciting, the kind of things that you can do with pervasive capabilities deep in the network. That reduced latency is key to application performance. And we can talk about that in more length. But to get there, first we must solve for lifecycle management. Wiqar.
Thank you. All right, thank you. I think that was awesome. I think part of the excitement for me being here today is to be in between these two guys here. I think a lot of the things that we're doing are similar. A lot of the things that we're doing are going to be complementary. And I really want to focus on the actual thing that we're looking to solve for as providers of edge computing capabilities. So our system is called NALEJ. And the idea behind NALEJ is to enable edge cloud computing to just be cloud computing. Just piece of infrastructure should just be a piece of infrastructure. So the way that we approach the market for edge computing, we don't delineate between what is an IoT device versus what is a cloud device versus what else is out there. We do recognize that there's, as John mentioned, there's lifecycle management issues, and we treat the lifecycle management issues in a unified manner. And we delineate the lifecycle management based on whether we manage the lifecycle for that piece of infrastructure or somebody else manages the lifecycle for that piece of infrastructure. So again, when we think about infrastructure and what is represented by infrastructure at the edge, it's about unifying and monitoring that infrastructure, regardless of whether that infrastructure is living in the cloud, living in a private data center, underneath this guy's desk, which I bet he's got some, or if it's a drone device, or if it's a mobile phone. So for us, it's about how do we create a system that allows the specific people that are responsible for provisioning that infrastructure physically, operating that infrastructure at scale, work together to be able to deliver the type of connectivity that's going to be required to solve really pressing challenges as we move forward. I would tend to agree with my colleague
Chad
here on the left about app lifecycle management. So similar to how we have unified infrastructure lifecycle management, we also focus on unified application lifecycle management. So if you take a look at how the problem is being solved today, there's a lot of providers of application lifecycle management that focus on the application lifecycle in cloud, the application lifecycle on the IoT device, the application lifecycle of the data that gets communicated from that IoT device all the way back to cloud. Again, one of the challenges that we're trying to solve for is how do you unify that as a single contiguous application? How do you take these 3 disparate types of application problems and then just turn them into one problem and enable the right type of users along the way to do the job that they're supposed to be doing and make that seamless? So, our motto is what is edge computing? Well, edge computing is all about running everything like an app, whether it be your car, your city, your factory, your home. It should be as simple as building an app for your iPhone. And the things that I think we're all up here trying to solve for is how do we enable that so that it can be done by a small group of developers as opposed to an army of developers, right? So just a quick peek under the hood. One of the things that we strive for as part of being this edge computing platform is to present ourselves as close to well understood nomenclature as possible. So when we think about what is cloud computing today and how many people understand cloud computing today, when we bring our perspective on edge to the market, we want to capture as many of those skills that people have built up over time so that they're transferable. As we build up the new necessary skills to move forward into this edge computing world, we need to not leave behind our old ones. So all of our systems are put together so that they present themselves as close to existing cloud computing paradigms as possible. From a logical point of view, we again do the same thing from a breakdown in roles and responsibilities. So the left-hand side really represents operators, where they're responsible for provisioning the resources. Then our systems then step in to help understand what those resources are, what those capabilities are, what's the connectivity between all of those resources and the capabilities. And then the users, the business users, are then presented with the ability to control the different things that they are interested in controlling: cost, performance, security, et cetera. The right-hand side really represents the developers, right? And the types of developers that all need to participate together in this ecosystem of edge, whether it be IoT developers, whether it be infrastructure developers, and the type of control that we want to give to them. And then ultimately, we want to simplify this picture of edge computing to, hey, here's your infrastructure. Here's how all of your infrastructure is connected. Here are your applications running on that infrastructure. Here's how they communicate with each other to ensure that they're secure, that other people aren't going to be able to do malicious things. Here's how your IoT devices connect into that infrastructure and the applications that are associated to that edge. But at the end of the day, what are we really trying to do here? We're really trying to help everyday people realize what is edge computing through the everyday things that they do, whether it be adjust your Nest thermostat by your phone, because that is edge computing, or it be early on, I had a picture of a flying car that's being produced by one of the aircraft manufacturers that we work with. I want people to be able to fly in automated cars because that's the future that we were promised. And if we don't build that future ourselves, nobody else is going to do it for us.
Thank you. Hey, so I'm Zack. I work at, while we're swapping over slides, I work at a company called Tetrate. One of the, I wanted to talk a little bit about my work history just because I'm sitting in this room a little bit different than I think most of the crew that is here. So in particular, I came from the cloud provider side of the world. So I'm looking at this problem from the perspective of the applications that are going to be running in the general compute that we're building in Edge, right? So this is the ultimate goal. As the folks in this room are building out these Edge networks, they're adding the capability for us to start to do more general computing there. For all the reasons that we've talked about, the latency, the bandwidth, and so I'm coming at this from the perspective of how are we actually going to start to run our applications, much like the folks here. In particular, I work on a project, an open source project called Istio, which is really all about kind of application networking. So real quick, Tetrate itself is a relatively new company, about 1.5 years old, pretty small team, globally distributed. And the goal is to let companies, let developers go faster with the applications that they need to deliver, right? And so I wanted to just kind of lay out what I see as some of the similarities that the application developers have that are being solved at a different layer by this community. In particular, if we look at the overarching problems that Corp is tackling at lower layers of the stack, this disaggregation, this move to white box hardware and open source software or software in general. And in particular, ONF's model about service chains. I think this is the goal that we need to keep in mind, right? This idea that as we start to ship applications towards on edge that consumers are consuming, or that users are consuming, how do we account for the mobility? How do we account for identity, for example? I think security is probably the single most pressing problem from an application developer's perspective as we start to do these new environments. Because our security models are predicated on old school thought on network identity. Network identity isn't very valuable when things are moving radically. We need to start to push identity up to higher layers to the application itself. This starts to let us write policy around communication that's not tied to physical infrastructure, that's mobile, right? When we talk about edge, mobility is a key piece, right? We need to stay close to the users as they're moving about in their world. Obviously, underlying connectivity is a basic piece. But one of the things that we haven't talked about, since this is a networking group, we haven't talked about the data very much, but calling home to where your user's data actually lives. Parts of that data will migrate into the edge cloud, right? But by and large, a lot of that is going to remain at home in those clouds, right? So how do we ensure connectivity and in a way that meets the performance requirements of the application that I'm running, right? I put it on edge because I needed low latency, high bandwidth compute close to my users. If I have to round trip home to get the data that they need, it doesn't do me any good, right? So that's the first piece, but then the policy around access is one type of policy that we need to start to push into our networks. Access control is only one very small one, right? Quality of service, and not just network quality of service, but quality of service as perceived by an application user, right? Maybe this request really is more valuable than that other request that looks very similar from the network's perspective, because the user that clicked the button pays me more money. I better treat that one more importantly, right? How do we start to do those kinds of policies and enable that in our network? And then the final kind of challenge that I think is interesting to look at, and I think that this is actually one of the most fundamental challenges that we have, is how do we actually start to model this? How do we start to describe this functionality? We all, I think, agree that we need to get to a declarative model of even more so than today, right? So today we have this YAML that stands in for what a declarative specification of my application is. That's clearly not sufficient in many different ways, right? If I ask people how you model a service at your company, probably every single person here would tell me a different set of answers. We need to start to develop a robust set of models for services, and not just services, but their behaviors, their runtime characteristics, their runtime requirements, right? The full DAG, the full set, the graph of resources that are required, really need to be present. And the ONF is one of the groups that is pushing this. But I think that this really needs to be picked up along a larger set of people if we're going to get to some of the worlds that y'all are talking about, right? Where we enable normal, right? The goal is I want to be able to take a normal application that I've been running in cloud, and I would like to be able to move it to edge and really not have to change a vast amount of it to start to realize those benefits of that placement, of that lower latency, tighter users. So that's all I got.
Okay, thanks. So if you feel compelled to ask a question, go to the mic and we will do that. And I will make sure we leave enough time at the end as well. But I wanted to circle back and ask each of you to comment on something, which is you're building platforms. You're trying to make them programmable so that I can build applications. So it's kind of a two-part question. The first part is, what are the applications that are driving this? What's the killer app that you hope will be your first app that carries your platform out there? And sort of related to that is because the 5G, the RAN part of this is one of the access technologies that is probably going to be front and center. As you think about your programming models for this edge site, to what extent are you taking into account that I'm actually, that SDK also may give me something about the connectivity? It's not just IP pipe. It might be, I need this particular value that only the RAN knows how to give me, and I need to go in and figure out how to turn my slice on in the RAN. So two-part. One, what's the application driving? And two, how tightly bound and dependent is that upon the access technology? And if anyone wants to volunteer, otherwise I'll just go back the way we came.
All right, somebody want to tackle first?
Yeah, go ahead.
Oh, this one probably don't need.
Yeah, right. I don't need that.
John, if you
This
want
is the token we're passing,
That's
right?
the token. So, right, let me say a little bit about RAN and the application. So from an application perspective, as a platform as a service vendor, I don't care. What do I see as maybe really driving edge? The classics are 5G connectivity, mobile phones, accessing data, perhaps while moving. I see some exciting public service opportunities there in transportation, for example, getting information about road hazards to the vehicles that are traveling down an Autobahn, for example, if the traffic's going to stop. I believe they already have some amount of this in place, but those kind of opportunities grow and develop. I also see a lot of potential for e-commerce, retail, those kind of business-to-consumer applications in which an app has a highly interactive or highly chatty user interface to the users that are out there that demands the low latency. They also have another part that is data and a transaction-oriented database. OLTP transaction databases are very difficult to spray across thousands of edges. So those will remain in a few large locations with stable storage, great backup, multiple availability zones. Given that, I see applications being teased apart. Certain components will go out to the edge. Others will remain local. And I'll get to the RAN in just a bit. But I think that the edge computing offer for a highly dynamic and personalized user experience is really powerful and motivating. Now, at the edge, my background has always been IP and above. So the RAN question, the way I answered Larry when we were talking about this casually earlier is, I don't care how a packet gets to me. Thinking about it a little more, it's an interesting question. Which components, as you take a monolith and you break it into containerized microservices, some of those services go to the edge, some stay core. Which of those services go into 100 internet edge locations? Which of those should go into 1,000 central office edge locations? And which should go into the 100,000 access locations? As I think about this, in terms of mobility, as I move from access point to access point, if there's any state required in my application, it's not going to be in the next access, under the next tower. So it's key to have your state in, to the previous example, that distributed KV store. That's going to be a key component. And I see a lot of value in putting applications in CO edges, but the containers I have in mind don't go all the way out to RAN. Maybe that's my limited thinking, but that's where I'm coming from.
So I think I'm going to start the answer by, look, you guys are building all of this really, really hard, deep infrastructure technology. And part of the things that we're all up here advocating for is how do we use our companies and our products to enable the world to realize the things that you guys are contributing to the ecosystem. So, for us, I'll answer the first part of the question, which is what are the workloads that are really driving our commercialization? We have two types of workloads primarily. One is going to be in the enterprise, where we really look at ourselves as something that helps accelerate the transformation of enterprise transformation. And then the other type of workload that we work with is specific to companies that have more and more compute going out to machines. These could be industrial manufacturing machines. These could be machines that are out there in the field somewhere. That's where our primary focus is right now. With respect to how we leverage the network, let me give you two examples, one on the commercial enterprise side and one on the industrial side, right? So for us, again, I'm with John. I don't know too much about how the underlying stuff works. We're an overlay on top of what you guys provide us. But as an end user, there's a very simple, very old enterprise use case that really bothers me. It's VDI, and it's the video part of that really, really, really bothers me. So if there is a better way to push transcoders and encoders to the edge, and then you guys can help us do that, then yeah, that would be one way that we can take advantage of your technology and build something in to enable our developers to do special things with those transcoders and encoders. And then from the industrial side of the business, the types of communications that we may get need to be tiered. There may be communications that need to be super secure, that need to go for compliance reasons through a specific path. I think that could be another huge benefit for us in terms of how we leverage the underlying network.
So in terms of applications that I see driving edge, I can really only speak for the applications that I am working with customers that are deploying.
Here. Yeah.
And today that's predominantly financial companies. And so for me and my company, and so they're interested in things like time to approve a decision for a credit charge is critical, right? How can I start to push the online abuse detection? How can I start to push that decision making closer to where consumers are actually swiping their credit card, right? This is historically one of those interesting areas where we have TCP connections that live for months and years and things like that, right? So there's all kinds of interesting, fun challenges in that space. In terms of things like how do we start so your RAN question, I'll broaden a little bit to, hey, these applications need to start to utilize the underlying infrastructure, the underlying network to achieve their capabilities. How do we do this? And this is really what I intended when I started to talk about the lack of a model today, right? So those style resources that an application needs. Hey, I'm going to be deployed into this environment where I have the capability to access these things. I want to use them. I want to use the best in breed of any of the capability of whatever environment I'm running in. Our models need to start to capture those requirements when we describe a service that needs to go and be realized, right? The second piece is once we have models that describe that, how we realize services starts we have options, right? Maybe for some particular functionality, I'll deploy an L7 proxy, that's going to do processing in software. Maybe we're going to push some of that functionality into the actual switch fabric itself. But we can't start to make global decisions around where we implement given functionality unless we can actually describe the functionality that needs to be implemented and realized. So there's my...
I like that answer. If you have questions, I've got a few more minutes. Please go to the mic and ask. Not seeing anyone jump up, I get to ask my next question. I'm going to start with Zack as well, which is open source. You're deeply involved in open source, but I'd like just real quickly, we only have 5 minutes left here. The role it plays is the state, yeah.
Yeah, so I think it's a critical driver, right? I think that more and more the trends that we're going to start to see is that specs and standards are going to take a secondary seat behind implementations that actually drive the field forward, right? This has always been the case to some degree. We need a reference implementation for our spec. I think that is going to become even more the case. And I would argue that those implementations must be open source if they're going to make sense, right? It doesn't make sense for us to have a closed source spec. It doesn't make sense for us to have a closed source reference implementation. I think that open source is the key critical driver for this entire spectrum, right? So I'm seeing similar themes happen. Y'all are seeing it at L2 and 3. We're seeing it at, L4, L7, across that entire spectrum.
I'm going to jump in since we have a question, and we can come back.
Yeah, I was just going to ask. So, from a service provider perspective, I mean, we've heard today some of the things that were said about edge, and one of the things that I think I found the most important is the scarcity aspect in terms of the resources. Mm-hmm. So, I'm not really hearing anything in respect to how you manage that scarcity of resources, because from a network operator's perspective. The real difference between the edge and the core is that on the edge, I'm probably constrained to a small space, very limited power, and servers that I'm going to buy are expensive. So today, let's go, not even talk about the application, but let's go to the basics, the infrastructure management stacks of today, and the network packet processing applications of today generally require a bunch of compute just to stay up.
Yep.
Yes.
If you look at OpenStack, I don't know, you're looking at a minimum of
Don't look at OpenStack at the edge. Sorry.
But even if yeah, that's a good point. Yeah. That's actually a good point, because if I'm a network operator, I want to deploy, say, application like, I don't know, a DPI that then informs some content management application, content distribution, content filtering application at the edge, and then you go and look for it, and oh, sorry, unless you build it yourself, available DPI platforms require a bunch of resources.
I think these guys all, they're all chomping at the bit to answer this one, because I think it's what they're. Yeah.
I'd love to offer a perspective. So I mentioned distribution and placement as key elements of application lifecycle management, and that's exactly what I was going to. I didn't express, but you're absolutely right. The key differentiator of edge versus cloud is that lack of resource. One way to do this is to provide intent-based distribution of applications, allowing the app owner to apply the intent of where a thing should go, taking into account, for example, compliance with GDPR. But more interesting to me is taking into account end-user traffic, looking at where the endpoints are, the demand that they provide, and placing applications nearby the demand in order to meet, for example, a latency objective, a network RTT objective, not response time of the whole app, but the network latency. So that's one approach that we've taken at Rafay.
Right. So I agree. I think application lifecycle management is critical. Part of the approach that we take also has to do with the three core things that we provide users control over, which is cost, performance, and security. And we wrap the latency metric under performance. So when we unify the life cycle of the infrastructure, what are we actually doing? We're actually trying to inventory what is that infrastructure. So part of deploying the application has to do with not just the proximity of that application to the user, but the type of performance that you're going to get out of that application. So if we can orchestrate that application to best fit infrastructure first, to get the performance that you're looking for, then we can optimize for the latency, either based on that piece of infrastructure or the proximity to the user of that infrastructure, right? So then you have something to measure a trade-off against. And in order to do that, the tools that we need to be able to provide our end developers is we need to give them an understanding or an idea of what infrastructure is actually available to them, so that when they build their applications or package their applications, they can build and package them with a sense of how to optimize or tune that application for the performance that they're looking for, or the security characteristics or compliance characteristics that they're looking for.
Zach, do you want to add anything?
Yeah, I mean, so yeah, I think you're basically touching on this. This is the key problem that is going to be how network providers make money off of edge, right? At the end of the day, because it's a scarce resource, you're going to be running auctions to sell what compute is available to on demand, right? I think you're very correct that the software today is not there to enable that. I think this goes to Larry's open source question, right? I think that it's critical that a lot of that core fundamental functionality be developed in open source, because we need primitives that start to describe this stuff that are widely used, right? This also goes into the modeling question. Yet again, I know that that's been my answer to effectively everything. But when you start to model those resource requirements, then you can start to do auctions and sophisticated scheduling to actually accurately use the resources that are there.
Great. Well, we are just a few minutes over time, so I think this is a good stop point. Thanks to all three of you. This has been great.
Thanks. Thank you, Larry.